Alright, welcome to my YouTube channel. This is Dramani Online Mathematics. Today we are going to look at logarithm, and let's first look at what a logarithm is. Now if you take your calculator and you identify the log function that we have, let's say if you have log 100 to the base 10, you will see that you get your answer to be 2. Is that okay? Now, you also realize that from exponential functions or from indices, we said that 10 to the power 2 is what? 100. So relating these two together, you realize that the base of the log, which is 10, is the same as the base of the index or the exponent here, which is 10. The answer of this becomes the power here, and the power here becomes the what? The answer. It means that if they ask you to write this one in the logarithm form, what you are going to do is that whatever that they will give it to you, you take the base of that indices as your base of the logarithm, and the answer there becomes your power for the log, and the power of this becomes your answer. Is that okay? Now, in general, we said that if I have a to the power b equals c, if I want to write this one in logarithm, the base here will still be the base of my log. The answer become my power, and this one is equals to what? B. So that's how we convert from the exponent to what? Logarithmic function. Alright, now let's look at an example. Express two to the power 4 equals 16 in logarithmic notation. Okay, so let's see how we can write this one in log notation. 2 to the power 4 equals 16. So what is the base here? The base here becomes the base of the log, which is 2. Whatever you have here, the answer there becomes our power, and our power becomes what? Our answer. Simple as that. Alright, now let's also look at another example. So we have, for example, 2. Right. Let me use a black pen. Right 8 to the power negative 2 over 3, which equals 1 over 4, in logarithmic form. Okay, so looking at this particular thing, what you are going to do is very simple. First, you consider the base here. So what is the base? It's 8. So log also becomes the base of the log, and the answer here becomes our power, and the power becomes our what? Answer. Simple as that. Is that okay? So now let's look at laws of logarithm. Laws of logarithm. When we were doing the indices, we look at log of indices. So this one, you are going to look at laws of logarithm. Now, laws of logarithm. So first, you look at the first law. The law is saying that if I have log xy base a, so that's how we read it. The power will be mentioned first before the base. So if I have log xy base a, then this one can be expressed as log x base a plus log y base a. Please take note of the laws. They are very, very important here. So example, let's say if I have log 3 times 2 base 5, then this one can be written as log 3 base 5 plus log 2 base 5. Simple as that. Law number 2. Since we have multiplication, let's go to the division. X over y. So this one too can be written as log x base a minus, because of the division sign, you write it as minus. Then this will be log y base a. So if I have log a, let's use the base to be 2, 3 over 5. Then this can be expressed as 3. So log 3 base 2 minus log 5 base 2. Now let's move on to our next law. Okay, let me write it here. Law number 3, say that log a base a will give you 1. So if I have log 10 base 10, I'll have 1. So any number that is raising itself will give you what? 1, except 0. When a is 0 and this is 0, please, it is wrong. So it should be a number which is greater than what? 0. Positive integers. Because log doesn't take negative what? Numbers. Alright. Now let's also move on to log x to the power y base a can also be written as y log x base a. So example, if I have log 2 to the power 4, I can write this one as log 2 to the power 2 power 2. 2 to the power 2 base 2. So the 4 here can be written as 2 to the power 2, and already have base 2 here. And we are saying that this can be written as 2 log 2 base 2. And I've said that power and base, if they are the same, then that log would be what? 1. So here our answer would be 2. Is that okay? From this law. Next point, we have log a to the power 1 will give us 0. So anything to the power 1 will give you what? 0. Please, I've already said that the a do not assume zeros and negative numbers. So it should be positive numbers here. Alright. Now, so if I have log 100 to the power 1 or log 1 to the base 100, then my answer will be what? 0. Law number 7. Okay, so if I have number 3, number 4, number 5, so this side is number 6, okay. If I have log xy over z base a, then this thing can be written as log xy, because this is division, I write it as minus log z base a, and we know that this is multiplication, so from the first law I can write this one as x plus y minus z. So example, if I have log 2 times 3 over 5 base 10, then this one can also be written as log, I'm doing it straight, 2 base 10 plus log 3 base 10 minus log 5 base 10. Simple as that. Alright, let me clean this side.
Continue.
Okay. Rule number 7. If I have log x base a, now if I want to interchange this, let's say I want the a to be the power, the x become the base, then I have to take the inverse 1 over log a here, x here. That is how we write it when you want to interchange the power and that of the base. Take note of that. Now looking at this, let's look at an example. Let's assume that I have log 10 base 100. Now I want to bring the 10 as the base and the 100 as the power. I have to write it as 1 over log 100 10. Is that okay? Alright. This one we can apply the laws that we have already learned. So this I can write this one as 1 over log 10 power 2 base 10. So 10 squared is 100.
Yeah. Continue.
Okay, so from here I have 1 over, so I can bring this one to this. I have 2 log 10 base 10. So that will give me 1 over 2, because log 10 base 10 is 1. So our final answer will be 1 over 2. No, sorry. Okay, so log b base a. So now this is what we call change of base. You want to change the base, you introduce another variables. So if I want to change the base of this, then I will introduce another variable. But that variable have to have something to do with what you have here. So here I'm introducing x. So assuming that if I have this example, log 64 base 4, and I want to change the base, then I have to write it as log 64 over log 4. But the base that I'm going to choose have to have something to do with this and that. So if I choose this and that, that is 2. It means that 2 to the power 4, 2 to the power 6 will give you 64, and 2 to the power 2 will give you 4. So from this side, so 2 to the power 6 will give you 64, and 2 to the power 2 will give you 4. And here you apply that property, so you have to bring the 6 at the back of it. So you have 6 log 2 base 2 over 2 log 2 base 2. And we know that 6 log, so we have log, so you bring the 6 here, you have 6 log 2 base 2, then you bring it to here 2 base 2 log 2 base 2. And here we know that log 2 base 2 have the same base and the power, so it will go to 1. So I have 6 multiplied by 1, and this one will have the same thing, it will also go to 1, so 2 multiplied by 1. So then we are getting 3 as our final answer. So these are the laws of what? Logarithm. Alright, so let's solve some example. But before we start the example, take note of this. A log of base 10, let's say log A base 10 can also be written as log A. So it means that when you see a log without a base, automatic the base is what? 10. Take note of that. Alright, so let's look at this question, how we can go about this question. If you look at this one, anytime you are solving a log question, make sure that the coefficient of the log is 1. This around this is 3. So you have to bring this 3 top here by applying the law that says that if I have log, let's say A, B, and here is C, I have to write it as B log A, C, A base C. So it means that this B can carry top here, that's what is happening. So I can bring this 3 here. With that base means that it's base what? 10. So bringing it, I have log 3 power 3. So it is log 3 power 3 base 10, but I don't write the base, minus log 27 base 10. But we know that 3 to the power 3 is 27, minus log 27. I know that some of you will just write 0, yet the answer is 0, but you need to apply the law. What law are you going to apply here? You are going to apply, enter I have x base y, sorry, x over y. You can write it as log x minus log y. Please, I'm not bringing the base because I'm considering base 10. So if I have something like this, it means that this particular question, I can write it as log 27 over 27. Is that okay? Now, 27 over 27 will give us log 1. And remember the base is 10. And we said that anything or a log with power 1 will give us what? 0. So that is the answer. Indeed, this minus this will give you 0, but not always. So don't be in hurry towards subtract. You have to follow the law or the rules. Okay, let's move to another example. Express log 2z base 3 minus log x base 3. So we want to express this as a single logarithm. So let's see how we express this as a single what? Logarithm. So if I want to express this one, I have to apply the laws. This one is just subtraction. So it means you are going to what? Apply this law here. So let me rewrite my question. So having this, because they say they want us to write this one in a single logarithm, there's no need to apply the multiplication law here. I have to just combine it so that it will be single for me. So I have log 2z over x. And that is all. Very simple, right? Very simple. So let's look at another example. So now let's look at how we can solve this question. This is a very simple question. So you have to apply the laws very, very well. So now looking at this, they are all in base 10. So I have log 10, 75 over 10 minus, here I have to make sure that the coefficient of this is not 2, it's rather what? -1 here. So minus log 10. So if these two go there, I'll have 5 over 7, sorry, 5 over 9 to the power 2 plus log 100 over 243. So this is what I'll have. And looking at this squared will be, for me this is, you know this, I'll distribute it here and here. So it will be 5 squared, 9 squared. So I have my log 75 over 10 minus log, so 5 squared is 25 over 81 plus log 100 over 243. Now at this point, this is subtracting. So if I want to combine them, then I have to have 75 over 10 divided by 25 over what? 81 plus log 100 over 243. Now we are adding these two, so it means I'm going to multiply them by the loss. So I have log, by this division sign I can change it and write as times. So I'll take the reciprocal of this, that will be 81 over 25 times this, because of the addition sign, which is 100 over 243. Is that okay? Now, after getting this, what next? You just look at those that you can easily cancel them. 10 goes here, 1, and going is to 100, 10. 25 goes here, 1, goes here 3 times. Okay. Is there any cancellation again that we can do? Log 2430 over 243. Remember this is base 10, and this will definitely give you this. This one goes here, 1 goes here 10 times, and this is what? 1, because with a power and the base they are the same, so log of something like that will give you 1. Alright, so let's look at our final or last example for this. The question is saying that we should evaluate without using calculators or table this. So how can we do this? What you are going to do, look, here is base 2, base 2, base 2, here is base 4. Is that okay? Now our aim here is to be able to make this one to have power 2, power 2. You understand? So if I am able to make that one the same, then we can move along. But I know that this side I can write it as 2 to the power 3, which is the same as that. Then log, this one I can write as 2 to the power 4 minus 4 log 2 to the power 2 base 2, and all divided by this side I have log 4 to the power 2. 4 to the power 2 is 16. So now after writing this, I'm writing this 3 here. So that will give me 3 log 2 base 2 plus 4 log 2 base 2 minus 4 log 2 base 2 all divided by 2 log 4 base 4. Now this will give me 1, this will give me 1, this will give me 1, this will give me 1. So I have my 3 multiplied by 1 plus 4 multiplied by 1 minus 4 multiplied by 1, all divided by 2 multiplied by 1. So and then 3 times 1 is 3 plus 4 minus 4 over 2. So what are we getting? This will give us 0, so we have 3 over 2. That will be our final answer. Please, you can also go by a different way. So you can add this and break this one and divide and do it. You also get the same thing. Is that okay? Thank you very much for watching. Please, I released the video on logarithmic equation and how to use log to solve exponential equations. Thank you very much.